All right, so let's look at number 42. Um, Here we have a group of 4 men and 5 women, and we are selecting some of them to go to a conference. So anytime I'm selecting a group of people, I think, does the order matter? Since we're just taking a group to a conference, then the order doesn't matter, so this will be a combinations question. The first part says, in how many ways can 4 people be selected from this group of 9? So it doesn't say they need to be men or women, just if I want to take 4 people from a group of 9, how do I do that? So it'll be 9 choose 4. If I type that in, 9 choose 4, I get 126. Okay, that's part A. Part B says, in how many ways can 4 women be selected from the 5 women? So here they're specifying that we're choosing 4 women from 5. So 5 choose 4. That's going to be 5. And then part C just wants the probability that we choose all women. So all I have to do is remember that this is my denominator and this is my numerator for this question. So the probability of all women, okay, all women chosen is 5 over 126. If I could reduce that, I would. I realize I can't because that's 5. And this is not divisible by 5. So that's my final answer. All right, so that would be 5 over 126. All right, so let's look at number 43. We have some comedians or comics performing. So 6 stand-up comics, A, B, C, D, E, F, are to perform on a single evening at a comedy club. The order of the performance is determined by random selection. Find the probability that comic C will go last, comic D will be 5th, and comic C will be last, A will be last, and then this order. So first thing I got to do for number 43 is find the denominator, or that is all the ways we can order these comedians or comics. Okay, that's what we got to do first. So we have 6 stand-up comics. 1, 2, 3, 4, 5, 6. First, second, third, fourth, fifth, sixth. How many ways could we choose the first one? Well, if we got 6 comedians, 6 could go in the first spot. Now that I've put one of them here, I now have 5 left. 4, 3, 2, 1. So you may recognize that as 6 factorial, which is 720, I believe. Okay, so this will be our denominator. We need that number for the rest of part A. What is the probability that comic C will go last? So look, I'm going to do my blanks again. 2, 3, 4, 5, 6. C has to go in the last position. There's only one way I can put C in the last position. But I can still choose first, second, third, fourth, fifth, sixth, but the 6th has to be C, so I can leave that there, 6th. All right, so that leaves us with how many people that could still go first if we fix C to be last? Well, there's 5 that can go first, 4 that can go second, 3, and so on. So this turns out to be 5 factorial, which is 120. But they want the probability, so I shouldn't have circled that. They want the probability, so the probability that C is last is, this is the numerator, and this, like I said, was the denominator. So 120 over 720. And if I subtract 7 minus 1, I get 6. So 6 here and 1 here. I'm kidding. That's not really how that works. I could reduce this by doing 120 over 720. And notice I get a decimal, second PRB, and I get 1/6. Okay. That's part A. Part B says the probability D will perform 5th and A will perform last. Okay, so D 5th, and A last. Well, let's do my blanks again. So first, second, third, fourth, 5th, 6th. D goes 5th, so fix him there. And then A is last, so we're going to fix A there. And so now how many do we have that can go first? Well, we had 6, we had 5, now we have 4. So 4 could go first, 3 could go second, 2 could go third, 1 could go fourth. So this is 4 factorial, which is 24. Okay, so the probability that D is 5th and A is last is 24 over 720. All right, so that's probably going to reduce, and that reduces to 130. All right, and then part C. What's the probability that they will go in this order? Probability, we're looking for this order: C, D, A, B, E, F. Well, let me do my blanks again, and let's just see what happens. So first, second, third, fourth, 5th, 6th. All right, so that's C, D. It has to go in this order: C, D, A, B, E, F. And since I'm putting a letter underneath, that fixes their position. So that's one possibility. So the probability of this happening, so the probability of this order C, D, A, B, E, F is 1 over 720. Okay. So part D is the probability that it will be E or F will perform 4th. So E or F will perform 4th. So let's go ahead and do my blanks. 1, 2, 3, 4, 5, 6. They're saying E or F will go 4th. Okay, so this could be E or F. could go in this position. So that leaves us with 2 possibilities. Now, I've only chosen one of those. Even though I put a 2 here, that's just 2 possibilities, but I have only chosen one. So I had 6 total comics. I now have 5 that could go first, 4 that could go second, 3 that could go third, 2, 1. So these make 5 factorial. So I end up with 5 factorial times 2 times this 2. Okay, let's see. 5 factorial is 120 times 2 is 240. So the probability that E or F is fourth is 240 over 720, which is a third. All right, so yeah, I had already put the answers there, but that's how you get them. Okay. So I worked a video earlier for these problems, and then something happened with the video, so I had to redo some of these. So that's why you see some stuff already written, because I've worked them. Okay, so this is the maximum lottery question, max lottery or max jackpot. We'll call it max lottery. The troublesome question in the homework was that minimum problem, but this one's the maximum. So in this case, we're only purchasing 1 ticket, or what's the probability of a single ticket winning? So this one's actually easier than the min. So that's why we see that on the practice test. So first thing I'm going to do is find the denominator, find what we're dividing by. So player wins a jackpot if he matches all 5 numbers drawn from the white balls. So we have the white balls, and we have the gold ball. So you got to match all 5 numbers from the white balls. And there's a total of 45. So 45, choose 5 is how I find the white balls. And then for the gold balls, there's only one that's a winner, and there's 34. So 34, choose 1. So let's do that. I'm going to do both of those numbers. 45, choose 5. It's a big number. 1, 2, 2, 1, 7, 5, 9. And then I'm going to do the gold balls, 34, choose 1. Well, if there's only one correct ball that I'm choosing, then there's 34 possibilities. Okay, I could type it in. Now we need to multiply those numbers. 1, 2, 2, 1, 7, 5, 9. We get 4, 1, 5, 3, 9, 8, 0, 6. This is the denominator. Okay, there's only one winner. Only one winner, or one ticket, I guess is the probability. So the probability of the maximum lottery jackpot, this is nice because it's just 1 over this denominator here. 4, 1, 5, 3, 9, 8, 0, 6. So this is the answer. And that doesn't reduce the minimum jackpot question. We had to reduce some really hard fractions. This guy doesn't reduce, so that's our answer. All right. Number 45, we got a box of transistors, 14 transistors. 3 are defective. All right. So here's the question. If 3 are selected at random, what's the probability of part A, all are defective? Okay. So I guess first we need the denominator, part A. Well, before part A, let's find the denominator, find all the total possibilities, total number of ways to choose 3 transistors, because the question says 3 are selected at random. 3 transistors from 14. Okay, so that's 14. Choose 3. Is 364. Okay, so the 3 that I'm choosing from is not the defective ones. It's actually the 3 that we're selecting at random. So there's 14, choose 3. That's our denominator. Part A says all are defective. All are defective. So that means I need to choose all 3 of the defective transistors. Okay, so this is the number of defective ones. I'm choosing 3, and so there's only one way to do that. You can try it in the calculator. 3, choose 3, and you get a 1 there. So that's a 1. So part A, the probability that all defective is 1 over 364.